Okay, welcome back 20-1 students. We're now looking at the second lesson. We're going to keep working on simplifying rational expressions and stating those non-permissible values. What we're going to look at though with this lesson is just more complex problems. So meaning we're going to have maybe some more complex factoring. So you can find this lesson on page 377 of your workbook. So again, it says we extend the method of simplifying rational expressions to just more complex examples, and I want you to think more complex factoring. So remember I said in my last video that if you're having any troubles with factoring, make sure you go back to our previous units, such as the quadratics, that definitely have some factoring review, or make sure you send me an email with questions. Okay, so it says recall that when we divide an expression containing a variable, there are restrictions on the value which can be replaced for the variable. These are called the non-permissible values of the variable. Okay, and then remember, reducing rational expressions involves what we say canceling factors. So you heard me say that last video, what can you cancel out? But not individual terms. So you're looking for an identical binomial. So for example, if I had a plus 4 divided by, say, a plus 2 times a plus 4, what can I cancel out? I have an a plus 4 on the top and a plus 4 on the bottom. So I'm left with simply just 1 over a plus 2. Okay? All right, so let's go on to example number 1. It says, reduce to lowest terms, stating the restrictions on the variable. You have to make sure you always state the NPVs. So remember also last video, I had 3 steps. Step number 1, factor. Step number 2, state the non-permissible values. And then step number 3, which is simplify or reduce to lowest terms. So think this just means to simplify to the point where you cannot cancel anything else out. Okay, so look at A. We have 4t cubed minus 9t all divided by 2t squared minus 3t. So we definitely have to factor here first. So look at our numerator. What can I factor out of the numerator? I can simply only take out a t. So this is just factoring by greatest common factor. So if I take out a t, I'm left with 4t squared minus 9. All divided by, what can I do to the bottom? I can also take out a t. So I'm left with simply just 2t minus 3. Now, do we think we're done with factoring? We're not done yet, because what do you notice about 4t squared minus 9? So if I highlight this one right here, this is a difference of squares. Oops. So that's a difference of squares. So you have to keep factoring. It's not factored all the way. So this is going to be equals t times, how would I factor 4t squared minus 9? I can take the square root of 4t squared as well as I can take the square root of 9. So when I take the square root of 4t squared, I'm left with 2t minus the square root of 9 is 3. All times, this would be 2t plus 3. Okay, and then all divided by my denominator, which is still t times 2t minus 3. Okay, now step number 2 is state your non-permissible values. You'll probably notice that you could cancel out, say, the t on top, the t on bottom, and the 2t minus 3 on the top, and the 2t minus 3 on the bottom. You cannot cancel them out until you've stated your NPVs. It's very, very important, okay? So my NPVs in the bottom. My first one comes from the t. What can t simply not be equal to? This is just 0, because it's on its own. And then if I look at 2t minus 3, what would you say t cannot be equal to? Well, if you set this equal to 0 and isolate for t, this would simply just be 3 over 2. Okay, so now I've stated the non-permissible values. I can go ahead and simplify. I can reduce to lowest terms. So what can cancel out? I can cancel out a t on top, a t on the bottom. I can also cancel out a 2t minus 3 on top and a 2t minus 3 on the bottom. So my lowest terms is simply just going to be what's left, which is 2t plus 3. There's my final answer. Okay, so we've stated our answer in lowest terms as well as we stated our NPVs. Those are also very important. Okay. All right, so now we're going to look at B. I'm not going to worry about C here. So we're going to scrap that one so we have all the space to the right. So look at B. We have 2x squared plus 5x minus 3 all divided by x squared plus x minus 1. So step number 1, I definitely need to factor. But what do you notice that's in front of the coefficient of x squared on the top and x squared on the bottom? It's not 1. So you would need to factor out the coefficient. But what do you also notice about the numerator? If I try to take out the 2, can I divide 5 by 2 and 3 by 2? No. And then can I divide 2 in the denominator as well? I can't. So this is where we're going to see some complex factoring. Okay, so I'm going to split this up. I'm going to factor the 2x squared plus 5x minus 3 first. And then we'll factor out the 2x squared plus x minus 1. We'll factor that one separately. Okay, so 2x squared plus 5x minus 3. I cannot take the 2 out. So remember, this is where I'm going to have to multiply. 2 times negative 3, which equals negative 6. So think, what two numbers multiply to negative 6 and add to 5? This is going to be positive 6 and negative 1. So now when I go to factor this, I have to break the 5x into 6x and negative 1. We're going to be factoring by grouping. So should the 6 be grouped with the 2 or should it be grouped with the 3? Should the negative 1 be grouped with the 2 or should it be grouped with the negative 3? Okay, so it's kind of just like guess and check. So here I'm going to have 2x squared. Because the 6 can go with the 2 and with the negative 3, let's just put the 6 here first. We'll try it. If it doesn't work, then we'll switch it. So we'll have plus 6x minus x minus 3. So think, can I factor out something from the first two terms and can I factor something out from the next two terms? So out of the first two terms, what can I take out? Well, we can take out a 2x. So when I take out a 2x, I'm left with x plus 3. And then look at the next two terms. Can I take anything out? Well, the only thing I could take out is I could take out a negative 1 because I want it to look like x plus 3. So if I take out a negative 1, I'm then left with x plus 3. Perfect. So I have the same binomials, which is what I then need to factor out. So now I'm going to take out an x plus 3. And what am I left with? I'm simply left with 2x minus 1. So that's going to be our numerator. So there's a little bit of work to do there. Now let's factor out the denominator. Or sorry, I shouldn't say factor out, but let's factor the denominator. So we've got, I'm going to write it over here, 2x squared plus x minus 1. So again, we're trying to factor out that 2, but I can't. So I'm going to multiply 2 times negative 1, which equals negative 2. What two numbers multiply to negative 2 and add to 1? This would be 2 and negative 1. Okay, so decide, are you going to group the 2x with the 2x squared, or are you going to group it with the negative 1? Okay, try a combo first, and if it doesn't work, we'll just switch them around. So I'm going to write this as 2x squared plus 2x minus x minus 1. Okay, so take something out of the first two terms, take something out of the second two. What can I factor out of 2x squared plus 2x? Well, I can take out a 2x. So if I take out a 2x, I'm going to be left with x plus 1. Okay, is there anything I can factor out of those next two terms? Yeah, I can take out a negative 1, and then that's where I'm going to get my x plus 1 as well. Okay, I have two of the same binomials, which is what I need, so now I can factor out that x plus 1. So if I take out the x plus 1, what am I left with? I'm left with 2x minus 1. And here are my expressions factored. Okay, so perfect. Now I can put these back into my expression. Now I've kind of run out of space, so I'm going to do a little bit of erasing here. I'm going to erase up here in this corner so that I can finish it. Okay, so I'm going to keep writing, but in red. Okay, so now if I just rewrite these, my numerator was from here, x plus 3 over 2x, or times 2x minus 1. So we're going to have x plus 3 times 2x minus 1, all divided by, which was my numerator right here, which is x plus 1 times 2x minus 1. Okay, so there's my expression. I did step number 1, I factored. Now step number 2 is going to be to state my NPVs. So I'm going to have 2 of them. I'm going to have one from x plus 1 and one from 2x minus 1. So my first one is going to be x cannot be equal to, this is negative 1. And then I'm also going to have x cannot be equal to, this would work out to 1 over 2. Okay, now my last step, step number 3, is cancel anything out. I can cancel out the 2x minus 1s. Perfect. So then, don't mind the arrow, what are we left with? We're simply left with x plus 3 divided by x plus 1. There's my final answer. Okay, so it's exactly what we did from the first lesson, it's just now we have a little bit more complex questions, so complex factoring. Okay? All right, so that's example number 1. Now, moving on to number 2. It says, express in simplest form stating the values of the variable for which the expression is not defined. So they want us to write it in simplest form, and they want us to state the NPVs. In this one, we are going to do, let's do A, and we're going to do B. We're not going to worry about C. Okay, so A, this question, I'm going to put a star beside this one. This is a nice question because we're going to have to end up factoring a negative out of one of those terms. So look at this one. We have C minus 4 divided by 4 minus C. Now, you can see that these kind of look similar, okay? Some students will think, oh, these are the same. I can cancel the top out, I can cancel the bottom out. But actually, they're not. They kind of look similar, but they're not the same. What you want to do is you want to make sure they're written in the same position. So I'm going to leave C minus 4 on top the same. I'm not going to do anything to it. But I'm going to rearrange 4 minus C. So if I rearrange this, I get negative C plus 4. So now, once the variables line up and once the 4s line up, can you see that it's no longer, they're not the same? I can't just cancel those out. So if I want to make them the same though, I can just simply factor out a negative. So which one do we want to factor the negative out? Let's factor out of the bottom. So I'm going to have C minus 4, nothing changes there, divided by, I can factor out a negative 1. So now my denominator is C minus 4. Now it looks and is identical to what's on top. Okay, so again, step number 1 was to factor. Now we're going to state our NPV. So what's my NPV? What can C not be equal to? Well, it would simply be 4. Okay, now simplify. What can I cancel out? I can cancel out the C minus 4 on top, the C minus 4 on the bottom. So what are we left with? We're left with 1 divided by negative 1. What's 1 divided by negative 1? Well, that's simply just negative 1. Okay, so our answer is negative 1, and don't forget we had stated our restrictions, which is C cannot be equal to 4. I should also state, you guys, when you're solving these types of problems and you're stating your answer, I must see your simplified form, which is negative 1, and I have to clearly see what your restrictions are. Okay, so whether you tell me what your NPVs are like this, where I've circled them here, or you could also write your answer as this is equal to negative 1 and just put a comma and simply say C cannot be equal to 4. You could also write your answer like that, but you must always tell me what your restriction is. Okay, so now let's go to B. I have 2p cubed minus 4p squared, all divided by 16 minus 8p. So step number 1, let's factor. What can I take out in the numerator here? I can take out a 2p squared. So when I take out 2p squared, I'm going to be left with p minus 2. Okay, so there's my numerator. Now, all divided by, what can I take out of the bottom? I can simply take out an 8. So I'm going to be left with 16 divided by 8 is 2 minus p. So here, if we look at this question, it's kind of similar to the one we just did. The p minus 2 and the 2 minus p, they look similar, but they're not. So I'm going to rewrite 2 minus p switched around. So this is going to be 2p squared times, this is simply just p minus 2, all divided by 8 times, if I rearrange this, this is negative p plus 2. Okay, well, how do I make this the same as p minus 2? Now I have to factor out the negative 1. So we're going to have 2p squared times p minus 2, all divided by, when you take that negative 1 out, it can go in front of the 8. So this is like negative 8 times, this will become p minus 2. Okay, now that things are factored, now I can state my NPV. So what's my NPV? Well, p cannot be equal to 2. Okay, now I can cancel things out. I can cancel out the p minus 2 on the top and the p minus 2 on the bottom. I can also do something about this 2 and this negative 8. I can reduce that. I can divide each of those by 2. So on the top, I'm going to be left with simply just p squared divided by, what's negative 8 divided by 2? Well, it's negative 4. However, do we ever want a negative in the denominator? No. So I'm going to write a little note here that says don't put the negative in the denominator. All you have to do is put it in the numerator. You're just moving it up. Okay, so this is going to be equal to negative p squared divided by 4. That should be how we state our final answer. Okay, I don't want you to state it as p squared divided by negative 4. We'd rather you move the negative up to the numerator. Okay, and then we've stated our restriction, p cannot be equal to 2. Okay, so now moving on to the next page. Okay, so here's another word problem. So it says the area in meters squared of a rectangular field can be represented by the expression 12a squared plus 25a minus 7. So there's the area. And the length of the field, which is represented in meters, can be represented by 3a plus 7. This is the length. So I'm thinking this is a question very similar to the one we did in the first lesson. What you probably can notice, though, is that they're a little bit more complex. So it says, write and simplify a rational expression which represents the width of the field. So we did last time, we wrote out the formula. Area equals length times width. I know my area is 12a squared plus 25a minus 7. This is going to be equal to, we're given the length, which is 3a plus 7, times the width. How do I find the width? Well, I'm going to divide both sides by 3a plus 7. Okay, so now I'm going to draw a little arrow over here. My width is represented by 12a squared plus 25a minus 7, all divided by 3a plus 7. They want a simplified expression, so I have to break this down. So step number 1, like we've been doing, is to simply just factor. So if I look at the numerator, my coefficient in front of the a squared is 12. I don't like that. I want it to be 1. Can I take the 12 out? Unfortunately, we cannot divide 25 by 12, and we can't divide 7 by 12. So this is where we're going to have to factor kind of the harder way, I guess you could say. So let's do this kind of separately. Where should I do this on the page? I'm going to kind of go down into part B here. I'm going to take 12a squared plus 25a minus 7. Okay, let's factor this. So I'm going to multiply 12 times negative 7. Okay, what's 12 times negative 7? So 12 times negative 7 is negative 84. Now, what two numbers multiply to negative 84 but add to 25? So it might take a little bit more work, but it's going to work out to be positive 28 and negative, oh, I shouldn't say, sorry, positive 28. This is going to be positive 25. No, what am I doing? Sorry, guys. using my calculator here. 85 divided by 4. We're going to have, yes, sorry, we're going to have 28 and -3. So those are my two factors. So I'm going to group the 28 with the 7 and the -3 with the 12. So I'm going to write this as 12a squared minus 3a plus 28a minus 7. So what can I factor out of the first two terms? What can I factor out of the second two terms? So in the first two terms, I can take out a 3a. So I'm going to be left with 4a minus 1. And then the second two terms, I can take out a 7, so this is plus 7, and I'm going to be left with 4a minus 1. Okay, perfect. I have the same binomials, so now I can factor out that 4a minus 1, and I'm simply left with just 3a plus 7. So there are my factors. Whoops. Okay, so now I can put this back in the question, so this is going to be equal to 4a minus 1 times 3a plus 7, all divided by 3a plus 7. Okay, I've factored. Now what I want to do is state my NPV, or my restrictions. What can a not be equal to? So when I solve for a in the denominator, this works out to -7 over 3. Okay, can I cancel anything out? Yes, I can cancel out the 3a plus 7s, so we're simply left with just 4a minus 1. There's my expression to represent the width of the field. Okay, so now part B says, if the perimeter of the field is 54 meters, determine the value of A. So how do we calculate perimeter? So think of a rectangle. Let's say this is the width and this is the length. Remember, perimeter is calculated by adding all of the sides. So this would be like 2 times the length plus 2 times the width. I know the length. The length they tell us is 3a plus 7. I now know the width, which is 4a minus 1. So the perimeter is going to be equal to 2 times the length, which is 3a plus 7, plus 2 times the width, which is 4a minus 1. Distribute the 2 into each of your brackets. So we have perimeter is equal to, this is going to be 6a plus 14 plus 8a minus 2. Now I can collect like terms. So this perimeter is going to be equal to 14a plus 12. Okay, we're given the perimeter. They tell us it's 54 meters. So I can plug that into my p-value. 54 is equal to 14a plus 12. Now we just have to solve for a. So it's just a linear equation. So subtract 12 from both sides. 54 minus 12. This is equal to 42. 42 is equal to 14a. Now I simply just need to divide both sides by 14. So 42 divided by 14 is a equals 3. There's my value of a. Okay, and then the last part of the question, sorry, my writing's a little bit on top of it. It says the field has to be treated with fertilizer at a cost of $2.40 per square meter. Calculate the cost of the treatment. So if I know that A is equal to 3, I need to know what the actual area is equal to as a value. So remember, your area is equal to 12a squared plus 25a minus 7. We know a is 3, so let's plug that back into here. So this is going to be 12 times 3 squared plus 25 times 3, all subtract 7. Okay, when you plug these numbers into your calculator, this works out to 176 square meters. So to figure out the cost of the fertilizer, it's $2.40 per square meter. So if I know that the total area is 176 square meters, I'm going to multiply this by $2.40. So when we multiply by $2.40, this equals a total cost of $422.40. And there's your final answer. Okay. All right, last example we're going to look at, if we look at example number 4. So this is where we're actually going to see two variables. So it says simplify where possible and state the non-permissible values for x in terms of y. So they just want to know the NPVs for x. So same 3 steps that we've been doing for these last 2 lessons. Factor number 1, state the NPVs number 2, and then simplify if you can. So if we look at A, x plus y over x minus y. Is there anything that I need to factor? No, there's nothing I need to factor. Now, I just need to state my NPV. So remember, we get that from the denominator. So x minus y is what's in the denominator. I'm going to set this equal to 0 and physically solve for x, because they want us to write the NPVs for x in terms of y. So to isolate for x, I would just add y to both sides. So I would say x cannot be equal to, what's 0 plus y? Y. There's my restriction. And then can I do anything to x plus y divided by x minus y to simplify? No, it's already simplified. Okay, so there's nothing I can do further. Now look at B. X plus 5y divided by x squared minus 25y squared. So step number 1 is to factor. I can't take anything out on the top. So this is just x plus 5y divided by, the denominator is a difference of squares. So this is going to be x plus 5y times x minus 5y. Okay? And now my next step is to state the NPVs. And you know what, we're not going to worry about C, so I can write over to the right. So my NPVs, we're solving for x. So my first one, x plus 5y is equal to 0. How do I isolate for x? I just simply subtract 5y from both sides. So I say x cannot be equal to negative 5y. That's my first restriction. And then my next one is going to be x minus 5y is equal to 0. So I just need to add 5y to both sides. So I would say x cannot be equal to 5y. So to state my restriction, I'm just going to say x cannot be equal to, this is plus or minus 5y. There's my restrictions. Now step number 3, simplify. So can I simplify anything? Yes, I can cancel out x plus y on the top, and I can cancel out x plus 5y on the bottom. So I'm left with simply just 1 divided by x minus 5y. And there's my simplified solution. Okay? All right, so for the assignment, the questions that we're going to be able to do, number 1 is simply just reduce to lowest terms, stating the restrictions on the variable. So remember, this is just to simplify. Okay. If we look at number 2, express in simplest form, stating the values of the variable for which the expression is not defined. So again, we're just simplifying here and stating the NPVs, very straightforward. Number 3, express in simplest form, stating the values for the variable for which the expression is not defined. You do not need to do C. So you can cancel out C for number 3. And then number 4, we also don't need to do number 4 here. So we can cancel out 4. That's much too complex. Number 5, this would be a nice word problem. Make sure that you can do number 5. You're practicing that one. And then number 6, this would be a great one to do as well, because this is having 2 variables. And remember, they want you to state the NPVs for x in terms of y. And then number 7, we're not going to worry about number 7 here. And then number 8, we're not going to worry about number 8. And then we can do number 9, and we can do number 10. And that's the end of the homework assignment. Okay, so make sure you do not do the ones that I told you to omit. Those are far too complex for us to do. So you don't have to worry about them. Okay, so that sums up lesson 1 and lesson number 2. We have now learned how to simplify rational expressions as well as stating the non-permissible values. The last thing I just want to bring to your attention for this week are 2 additional resources I've found for you for videos. So if I pull up my screen here, The first link that I'm going to include here is the Math 20-1 Simplifying Rational Expressions lesson. So it is long, it's 50 minutes. Feel free to skip a bunch if you'd like. You don't even have to watch it. It's just an additional resource for you to take a look at. So it just goes through how do you state non-permissible values, how do you simplify. Okay, so these are just more questions that you can take a look at. And then another link that I'm going to provide you with is the Mac Prima YouTube link. So here, the rational expressions, there's introduction to rational expressions. There's also the Npvs, so you can look at that video. Not sure if it's going to let me click on that. And then you can look at the simplifying rational expressions, and then there's another simplifying rational expression. So those first four you would be able to kind of go through. Okay, so these are totally optional. I'm just giving you more resources if I didn't break it down enough for you guys. Okay, so those are your first two lessons for this first week. I will post again the homework questions that you're doing out of the workbook, as well as I'm going to provide you with a worksheet that you can also do. Okay, so please, please, please make sure that you email me if you have any questions. I am more than happy to help you guys, and I'm looking forward to helping you. So make sure you get in touch with me today or Friday. And then coming up next week, we are going to look at multiplying and dividing rational expressions. Okay, have a great day, everyone.